Hello everyone, welcome to this new session on uniform distribution. We see that the distributions which are going to be theoretical in nature can be broadly classified into two categories: discrete distributions and continuous distributions. Under the discrete distribution case, we saw about binomial and Poisson. Now moving to the theoretical distribution case, under the continuous distribution, we will be seeing about uniform, rectangle, or you also call it birectangular distribution, exponential distribution, and normal or Gaussian distribution in the following videos. So what is the basic difference between the discrete distribution and continuous distribution? Discrete distributions are going to be finite in number, so you make use of the summation as the mathematical operation over here. When it comes to continuous distribution, the data are in form of interval. The random variable is going to follow or take data between any given interval. So adding up using the summation is not quite possible. So what we will do is we will make use of integration as the mathematical operation. So for all the following cases like uniform, exponential and normal, the mathematical operation to be followed will be integration. Now let us quickly move on to the first continuous type of theoretical distribution to be defined, called as uniform distribution. Now coming to uniform distribution, how can we define it? A continuous random variable x. So we know that the word is continuous random variable. So you have to be defined in an interval. The random variable is defined in an interval. This continuous random variable x is said to follow a uniform distribution, or you call it by the name rectangular distribution, in any finite interval if its probability function is a constant in that interval. So say suppose you are going to have a line number and in which the quantities are going to be, this is your interval A, this is going to be your interval B. Between this interval, if the function is going to be a constant, the function is going to be a constant. So this will be the kind of diagram or the representation you will be getting. So between the interval A to B, what does this form? This is going to form something like a rectangular structure. This gives the name as the rectangular distribution for this interval. So what happens within the interval A comma B, the value taken by the function is going to be constant. And we know that integral from A to B, f of x dx is going to be equal to 1. We now say this is going to be equal to k. Now how to estimate the value of k? Integral from A to B, k dx is going to be equal to 1. So k into, what is dx on integration? X. So between A to B, you will have to get this value as x. So 1 divided by upper limit is going to be b and lower limit is going to be a. This is equal to 1. So what can you say about k? K is 1 divided by b minus a. So now this gives you integral f of x dx to be of the format integral 1 divided by b minus a dx. So this constant value k gets evaluated as 1 divided by b minus a if x takes the values between a to b. So now this becomes the formula for your uniform or rectangular distribution. So how it is defined? The function is defined as f of x is 1 divided by b minus a whenever x lies between the interval a and b. Now coming to the parameters, what are the things which is required to define this distribution? So the quantity required to define this distribution is the constants or the endpoints a and b. So you call them by the name parameters. We say symbolically that the random variable x follows uniform distribution with parameters a comma b. X follows uniform distribution with parameter a comma b. Now about the statistical averages, what are the frequently used one? Is the mean and the variance. Coming to the mean of the uniform distribution, it is given by a plus b divided by 2. A plus b divided by 2. So the endpoints you take, add them up and take the average of it. Okay. How about the variance? Variance is given as b minus a the whole square divided by 12. Now this can also be written as a minus b the whole square divided by 12 in some textbooks. So you can invariably use both of them, because a minus b the whole square and b minus a the whole square are going to be one and the same. So keeping all these basic things in mind, we will now move on to apply these quantities to estimate problems. So coming to the first problem, let us assume that x is going to be a random variable. Problem number 1, let x be a random variable which is going to be uniform in the interval -1, 1. Now find the following probability. Question number 1, probability of modulus of x less than 1 by 3. Second subdivision, probability of modulus of x greater than or equal to 3 by 4. Now we have been said the random variable is going to follow what distribution? Uniform distribution. In what interval? -1, 1. So how I can rewrite this as, this is the interval a, b. So now how to define your f of x? F of x is 1 divided by b minus a whenever a is less than x less than b. So we now have -1 less than x less than 1. So in which case what happens over here? Your f of x will be equal to 1 divided by, what is in place of b? You have it as 1, and what you have it in place of a? -1. So this is minus of -1. So f of x is going to be 1 divided by minus of minus is plus. So f of x is 1 by 2. So now having fixed this function which is going to be valid in the range -1 less than or equal to x less than or equal to 1, let us move on to estimate the probability of mod x less than -1 by 3, sorry, positive 1 by 3. So what is the first subdivision? Probability of mod x less than 1 by 3. Now about modulus. Modulus is a function that takes positive and negative values and return back the positive value of the input. So in which case how I can expand this function as, this is going to take positive of it and also negative of it and range between it. What is going to be the negative value? Negative of this data is -1 by 3. What is the positive of this data? Positive of this data is 1 by 3. So we say that x varies between negative of it to positive of it. In which case now we know that uniform distribution is a continuous integration. Okay, for a continuous case what you will have to do? You will have to use integration. So how to define this probability? This is going to be -1 by 3 to positive 1 by 3 f of x dx. So your function is defined as -1 by 3 to 1 by 3 f of x dx. Before moving on to apply, make sure that your limit is going to fall within the given range. This is -1, this is +1. -1 by 3 will be here inside and positive 1 by 3 will be here inside. So both the limits lie within the limit of -1 to 1. So we can just integrate them using -1 by 3 to 1 by 3. What is function f of x? We have defined this function f of x as 1 by 2 times of dx. So this 1 by 2 being a constant comes outside. What is integral dx? Integral dx is x between the limits 1 by 3 and -1 by 3. So this gives me 1 by 2 times of 1 by 3. Upper limit minus of minus will become plus with the lower limit. So this is 1 by 3 plus 1 by 3. It is going to be 1 by times of 2 by 3. This 2 and 2 cancels off, leaving you with 1 by 3. So 1 by 3 is the final answer. Now moving to the second subdivision. So how to move about the second subdivision? We have probability of modulus of x to be greater than or equal to 3 by 4. Greater than or equal to 3 by 4. Normally modulus works only for less than interval. So if we have a greater than interval, we will have to convert it by taking its complement. What will be the complement? 1 minus probability of modulus of x less than 3 by 4. So now how to break open this modulus? This varies between negative of it to positive of the 3 by 4. So what is negative of 3 by 4? Minus 3 by 4. What is positive of 3 by 4? 3 by 4. So where does our x vary? X varies between minus 3 by 4 to plus 3 by 4. Again, before applying, please do check whether the data lies within the interval. Yes, minus 3 by 4 is a number less than minus 1 and 3 by 4 is a number less than 1. So they both lie within the interval minus 1 to 1. So I can say 1 minus, this probability can be written as minus 3 by 4 to 3 by 4 f of x dx. Now since our function is uniform in the interval minus 1 to 1, we can write this as 3 by 4 to 3 by 4. What is the value of f of x? This can be replaced as 1 by 2 times of dx. So it is 1 minus 1 by 2 comes outside. Integral dx is going to be x between 3 by 4 and minus 3 by 4. So you can make it as 1 by 2 times of 3 by 4 plus 3 by 4. Upper limit minus of minus will become plus. So it is going to be 1 minus 1 by 2, 6 by 4. 6 goes how many times? This goes 3 times. So it is 1 minus 3 by 4. What will be 1 minus 3 by 4? This will be 1 by 4. So this completes the value for your first subdivision, or second subdivision of the first question. Now moving on to the next problem, problem number 2. A random variable capital X is going to be uniform in the interval minus 3 to 3. Find probability of modulus of x minus 2 less than 2. So now again the function has been given us what distribution? Uniform distribution. So what will be the function f of x? It will be 1 divided by b minus a, for a less than x less than b. Now the interval is minus 3 less than x less than 3. So this will be 1 divided by 3 minus of minus 3. So this will be 1 divided by 3 plus 3. So it makes it as 1 by 6. So what is my function f of x? 1 by 6 for minus 3 less than x less than 3. Now coming to the problem, what is the problem which we require is probability of mod x minus 2 is going to be less than 2. So this modulus is going to vary for positive and negative of 2. So negative of 2, positive of 2, and my modulus is going to be lying within it. So what is the value of the modulus? X minus 2 is going to be lying between minus 2 and plus 2. Now balance this minus 2 to both sides of your inequality. So you will have minus 2. When this minus 2 comes to this side, it will become plus 2 less than x less than. When we balance it to the opposite side, this gives me 2 minus 2 when it comes here will become plus 2. So this makes it as probability of minus 2 plus 2 is 0 less than x less than 2 plus 2 is 4. Now when we visualize it in the line number, what happens? The line number is between minus 3 and plus 3. But where is this number 0? Yes, 0 is going to be over here. And where is this number 4? This number 4 is going to be here. The function is defined only between minus 3 to 3. What about the limit from 3 to 4? The value taken by the function f of x in the limit 3 to 4 will be equal to 0, because we know that this is going to be 0 elsewhere. And hence what happens is we can integrate it only between 0 to 3, and between 3 to 4 what happens to the function? It becomes 0. So now moving on to the application of it, 0 to 3 f of x dx. So this becomes integral from 0 to 3. What is our f of x? 1 by 6 dx. 1 by 6 is a constant. Pull it outside. X on integration gives you 3 to 0. So this is going to be 3 by 6. So the value will be 1 by 2. So the final answer for the probability of mod x minus 2 less than 2 will be 1 by 2.